welcome little scientists to another episode of Stay at Home Science, brought to you by the South Brunswick Public Library. I'm Allie, and today we'll be making a lava lamp. Alright, so let's get started. First we'll need to gather our ingredients. We're going to be needing some vegetable oil. I'm using some old cooking vegetable oil, water, a funnel, some Alka-Seltzer tablets, some food dye, and some kind of container. You can use a glass container, a water bottle, a cup, whatever you have on hand. I do recommend using something a little tall like this bottle. It'll make the experiment look a little cooler. And as always, don't forget to grab a grown-up. So to start with, we're going to grab our bottle and we're going to use our funnel and we're going to fill up the bottle about 2/3 of the way with the oil. So that's probably about right here. You don't really need to measure for this experiment. You can if you'd like, but I just recommend eyeballing it. So I'm going to pour in. Like I said, we're just going to pour it in and fill it up until about 2/3 of the way. Yep, right about there. Doesn't have to be exact. We're going to pour in our water, and we're going to pour it about 1/3 of the way, so about how much you see that's left. I am going to leave some room at the top so that it doesn't explode later on. A little bit more. The water is about 1/3, and then the oil is about 2/3 of the container. It's going to be the same for any kind of container you use. So if you use a smaller one, it's the same kind of measurements. 1/3 with water, 2/3 with oil. Next, we're going to be using our food dye. I recommend doing about 8 to 10 drops. And then you're just going to wait a minute to let all those bubbles kind of calm down. You can kind of twist it to get the food dye sorted into the bottom. While we wait, let's talk about what we see so far. We can see that the water and the food dye sank to the bottom of the bottle, while the oil sits on top. Why is that? That's due to density. If we measured the same amount of oil and water, we would actually see that the water is more heavier or dense than the oil, and that's because water is made out of molecules that are packed more tightly together, making it heavier than the oil. So the density is what helps the water travel to the bottom of the container. But what helps them not mix together? Well, that's due to intermolecular polarity. It's a big fancy science term, but at its basics, it just means that water is polar. It has an electrical charge that attracts other atoms. One end is going to be negatively charged, and the other end is positively charged. That means that water molecules attract other water molecules. But oil is nonpolar. It doesn't have a negative charge or a positive charge, meaning when the water and oil come together, they just won't mix. Alright, so now that we know some of the science behind this, and it looks like all our bubbles are pretty much gone, let's get to the next step. So we're going to take our Alka-Seltzer tablet, open it up, and we are going to take one of the tablets and break it up. This is just going to help the experiment go a little quicker. Next comes the magic. We're going to drop these into there, and it should start. Alright, so we already see some kind of reaction is happening at the bottom here. Let's turn it so you guys can see. Looks like we made a lava lamp. Now, I'm going to add another tablet and keep the bubbles going. was cool, right? So we made our lava lamp, and how were we able to get this reaction? Well, when the Alka-Seltzer mixes with the water, it creates gas bubbles that are known as carbon dioxide. Those gas bubbles travel upwards because they're less dense or lighter than the oil and the water. And those bubbles actually trap some of the water in them, which is why you see them traveling upwards. Once they get to the top, the gas bubbles pop and the gas releases into the air, while the water that's dense travels back down the bottle. This repeats until the entire tablet is dissolved. So that means that this lava lamp is temporary. But whenever you want to activate your lava lamp, just drop another one of these Alka-Seltzer tablets in there. Now, let's do this again. And let's see what happens when we add in 3 of them. Thanks so much for joining me on this episode of Stay at Home Science. If you guys do this at home, please tag us on our Facebook, Instagram, or even send it to my email. We would love to see a picture or video of you guys. Thanks so much for all your support. Don't forget to subscribe to this YouTube channel for more South Brunswick Public Library content. See you scientists later. Bye!